Hey, hi everyone. Today we are going to solve this problem. Okay, the problem name is merge sorted array. So the question itself is clarifying what we need to do, and let's understand what we will follow the steps into this particular video, right? So first of all, what we will do, we will just understand the problem. Okay, and then we will understand the brute force solution, and we will code it. Third, we will understand the time complexity of a brute force solution and code, and after that, we will understand the one of the best and tricky part of this particular question, and we will build the optimized solution on the top of it. Okay, optimized solution and its code. So in this case, so question is you are given an array, two integer array, nums1 and nums2. Okay, so there are two integer arrays sorted in non-decreasing order. Non-decreasing means ascending order. So this is clear, right? So we have to merge nums1 and nums2 into the single sorted array. So we have to merge both of them into the single sorted array into one of the array, right? So the final sorted array should be returned by the function, should not be returned by a function. So you can see the return type of function is none, right? So we don't have to return any function. What is given is we have a nums1 which is having a length equal to m plus n. M is a number of elements into the nums1, n is a number of elements into the nums2, and we have to merge all these elements into the nums1 itself, and we don't have to return that particular elements. So they are saying, but instead of a stored, instead we stored inside the array nums1. Yeah, same. We don't have to return the array, but we have to just store all the sorted elements into the nums1. To accommodate this, all the elements, nums1 has a length of m plus n. So suppose this is m, which is 3. So these are the three elements, first three elements, which needs to be considered for the merging process from the nums1. You can see this is a nums1, which has a length 3, and this is a nums2, which has a length 3. And we have to merge all these elements into the nums1. Is question clear to you? Okay, fine. So let's understand another example. This is a nums1 with length 1. So you can see length of a m is 1. So we have to consider only one element for the merging process, and the nums2 is length 0. So there are high level two solutions. First solution is we can use extra space to do this merging process, and the second is without extra process also, by just one trick we can solve this problem in place. Okay, so let's try to understand with the brute force solution first, and later on we will go to the optimized solution.
Let's consider this example. This is a first array 1 comma 3 comma 0 comma 0. This is a second array 2 comma 4, and this is a value of m. Numbers to be considered from the first array is 2, and this is a value of n numbers to be considered from array 2 for the merge process. So the brute force is, first of all, we can use extra space. So create a new array, keep one pointer here, keep second pointer here, and check whichever is a less element, right? If we compare, we will add that element here, and we will increment the pointer. Okay, and again compare the elements. So whichever the value is less, add that value and increment the pointer. Again compare the values 3 comma 4, add that value and increment the pointer. So you can see the current pointer into the first array has gone ahead or equal to the m. So in this case, what we will do, we will just check whichever is the pointer which is still into the particular condition. If a p1 is less than m or p2 is less than n, mean there will be some elements which needs to be added. In this case, we will just add the remaining elements from the array where this condition is not breached. So let's take one more example. This is array 1, 1 comma 3 comma 4 comma 0. So this is the array 2. In this case, we will have one pointer here, one pointer here. Create a new array, compare the values. You can see there is a one value less than the second, so add that. So P1 will come on the second value. Again, compare the values, add that, move the P2 ahead. P2 has reached the value of n, which is 1 because length of the second array. And you can see one of the pointer has reached that condition. So whichever is the remaining pointer, which is still under the condition, like this P1 is less than m. In this case, just add the remaining elements. So that is a brute force approach where we can use a extra space, and time complexity will be, because we are visiting each elements once, m plus n. And again, we have to return the existing array only. So we have to populate those values into the existing array again. So there will be a second iteration also, O of n plus m, and space complexity will be O of m plus n to use the extra space. So we can reduce this, but before that, let's try to code this brute force solution.
As previously discussed, let's try to code the solution. So first of all, take two pointers, p1 equal to 0, p2 equal to 0 for the respective arrays n1 and nums1 and nums2. Then take one answer array or answer array where we will just keep all the sorted elements one by one. Now take a loop while p1 is less than m and p2 is less than n if nums of 1 p1, the number on the p1 into the nums1, if it is less than nums2 p2, the p2 is pointer for the nums2. If that is the case, add that element to the answer array, the number on the p1 into the nums1. So answer dot append nums1 comma p1. Increment the p1 as we have added the number into it, number into the answer array. Else, just add, just repeat this condition, but for the nums2 to and increment the p2. And once when one of the pointer will reach the end condition, right? Then just check whichever is remaining. If p1 is less than m, then answer dot append nums1 of p1, increment the p1. Or just check if p2 is less than n. If that condition is true, perform this step. Now we have all the sorted elements into the answer array. That is our first iteration. And again, we have to put all this element into the nums1 because as per the function requirement, we don't have to return the array. We have to put all the elements into the num1. So while or just iterate over the elements into the answer array for number in answer array, just okay, let me do like this, for index in range of length of answer array. Now while iterating, add each element into the nums1, nums1 of index equal to answer of index. Let's try to run this. It is working fine. The time complexity for the brute force will be O of m 2m because or m plus n, and again, or what we can do, we can do 2m comma 2n, which will boil down to O of m plus n. because we are putting all the sorted elements into the answer array, and again we are crazing over the all elements again to put it into the nums1, and space complexity will be O of m plus n, which is a answer array. So that is a brute force solution. Let's try to submit this. Yeah, it is working fine. Now let's see how can we optimize this space with the same or lesser time complexity.
As we have covered the brute force solution, let's try to think it like can we reduce the space complexity and time complexity. So consider this example. Suppose this is array 1, 1 comma 3 comma 0, where value of m is 2, the number of elements to consider into the first array. This is a second array which has 2, value of n is 1. So can you consider thinking in the reverse direction, iterating over the reverse direction? So suppose, let me repeat this example, 1 comma 3 comma 0, and let's say this is 2. In this case, suppose here is one pointer, this is a current pointer, this is a p1 pointer at m minus 1, and this is a pointer at p2, like pointer p2 at n minus 1. So compare the p1 and p2, whichever is a greater element, right? So put it at the current element. So suppose the 3 will come here, and current will go back here, and p1 will go back here. So this will be c, and this will be p1. Now again compare the p1 and p2. In this case p2 is greater than the p1, so put the p2 here and decrement the p2, and decrement the c also, which is a current pointer. Now current pointer will point to 0th index. Now again check, the p2 has came out of the range, p2 is equal to minus 1, right? So this loops break. So whichever pointer is still in the range, whichever pointer is still greater than minus 1, so put those elements there. So this is 1 2 3. So you can see we have sorted the array in place without any extra space and without any extra iteration also. So space complexity will be O of 1 because we have not used any extra space apart from 3 variables, and time complexity will be, we will be visiting each element only once, so time complexity will be O of m plus n. So that is about optimized solution. The only thing we need to remember is we should start thinking in the backward direction if we can reverse the, if we can traverse the array into the reverse direction, and we will just refill all the elements by comparing the values. So let's try to code this.
As we have covered the optimized solution, let's try to code this. So this is a first pointer into the nums1, that will be m minus 1. This is a second pointer into the nums2, which is a n minus 1, and this is a current pointer which will be length of a nums1 minus 1. In this case, current pointer will be the last pointer of a nums1, which is this one. This is current, this is a first pointer, and this is a second pointer again. So loop over the both the arrays until both the pointers, first pointer and second pointer, is greater than minus 1. Matlab, while grazing from the backward direction, they should not reach 0. Matlab, they have not reached a 0. Like in that case only, we have to compare the numbers. So while first pointer is greater than minus 1, and second pointer is greater than minus 1, in this case only just compare the values on that particular elements. So if nums1 of a first pointer is greater than nums2 of a second pointer, so if this condition is true, the element into the nums1, if it is a greater than the element on the into the nums2, in this case just put that particular element on the first pointer on the current pointer, like this. So nums1 of a current pointer equal to nums1 of a first pointer. So let me make it small case. Reduce the current pointer and reduce the first pointer. Else, if element into the nums2 is greater than the first pointer, so in this case, just do the reverse. The element into the nums2 put at it into the current element. So this is a current pointer equal to this is a nums2. This is a second pointer. Now reduce both the elements, current pointer also and second pointer also. So current pointer is reduced and the second pointer is also reduced. In this case, you can see we are doing the same operation of reducing current pointer at both the places. So we can take it out of the if else. So let me take it outside. Now you can see this will cover whenever our both of the pointers have not reached the minus one. In the worst case, one of the pointer will reach the minus one and the other one is not. In this case, we have to just check if first pointer is reached the end, then skip it. If it is not reached the end, then populate the elements. So while first pointer is greater than minus one, just populate the same elements like this. Nums on. Let me clear the indentation. And this is a current pointer minus one. And we have to follow the same procedure for second pointer also, nums2 also. In the case of second pointer has not reached the end, second pointer, so this is a nums1, this is a nums2, put the same element into the current pointer. So this is a second pointer. That's all. This will cover all the cases. Let's try to run this. Yeah, it is working fine. So the time complexity and space complexity will be, here we are visiting each element only once. So the time complexity will be O of m plus n, and space complexity will be O of 1 because we are not using any extra space without three pointers. So that is all about the time and space complexity, and this is also important question. So please go through all the brute force approach and optimized approach also. Okay, chalo bye.